Welcome back to the deep dive. Today our mission is, well, pretty straightforward. We are tearing into a serious piece of enterprise gear.
We are the NTI SM-16X16-DVI-LCD digital video matrix switch.
And this is not a toy. It's really the brain of a high-density video installation.
Exactly. I mean, you see the price tag for this specific 16 by 16 model. It's $4,285.
Wow.
Right away, this is non-negotiable professional equipment.
Yeah.
What it does is simple in concept, but just massive in scale.
Right. It routes video.
From up to 32 different DVI sources, the
Yeah.
computers, players, whatever, to up to 32 separate displays.
That immediately sets the stage. Okay, so beyond just the sheer number of ports, the first thing you have to demand from a switch like this is quality.
And compromised quality.
Oh.
It uses a pure digital DVI-D interface for that. You get that crisp, clear video on flat panels.
And it handles your standard 1080p HDTV, but what really tells you this is for professional use is the computer resolution support.
Yes, all the way up to 1920 by 1200.
Which is WUXGA, that high-end workstation stuff.
The kind that needs perfect pixel mapping. And to do that, the sources say it pushes a video bandwidth of 1.65 gigabits per second.
A huge pipeline. So once it's in the rack, how does an administrator actually talk to this thing?
Flexibility is key there. You have like four main ways: the front panel buttons and an IR remote for when you're standing right there.
Sure, for local access.
But for a real control room, you're going to lean on the serial port, or more likely, the Ethernet port. It supports all the standards for HDTV, TCP/IP, you name it.
That network connectivity is just critical, and I was glad to see it's universal. Supports Windows, Solaris, Linux, Mac OS.
It doesn't lock you in, which is great. And this is where the routing gets, really sophisticated, specifically with EDIDE.
Explain that. What is EDIDE learning?
It's how the switch tells the source what kind of display is connected. It has to essentially pretend to be the monitor to avoid any glitches.
So it's not guessing. It either learns the display's actual profile or it can fall back on these built-in tables for PC and MA.
Exactly. It's to prevent those awful handshake issues.
Okay, speaking of connections, the docs note something interesting. The DVI port can actually pass HDMI audio and video signals.
It can, yeah, but you need a specific cable for that. And that brings us right to the biggest, most critical constraint you have to think about.
There's always a catch.
There's always a catch. And it's HDCP, high bandwidth digital content protection.
Copy protection.
Right. It is supported on the smaller models, but, and this is a huge but, it's only supported when you connect one input to one single output.
Wait, so the whole point of a 16 by 16 matrix switch is to connect one input to multiple outputs. That's why you buy it.
That is the fundamental use case. And the second you do that, the source documentation is crystal clear.
HDCP is not supported.
Not supported. It's a massive trade-off for any engineer who has to deal with protected media. It really demands some careful planning.
No kidding. Okay, moving past that hurdle, let's talk about distance and reliability.
So the pro sources highlight an option to use fiber optic extenders with this, these little ST2FO-DVI-LC units.
And what does that get you?
It lets you push that DVI signal almost a mile, up to 4,920 feet away.
That's immense, truly massive scale.
And for the biggest 32 by 32 model, it can even power those local fiber units itself, which cleans up the installation.
And what about reliability? If this is the brain, it can't fail.
Well, the meantime between failure, the MTBF, is listed at 48,326 hours.
Which is, what, in years?
That's over 5.5 years of expected continuous, 247 uptime. Plus, it's TAA compliant, so it meets those strict federal procurement rules.
So the final takeaway here is that this switch is a high-density, high-bandwidth beast for video infrastructure. It's built for huge capacity, but it forces you to make a really specific choice if you need to multicast protected content.
It's a workhorse with a big asterisk. Exactly.
Okay, so let's leave our listener with a final thought to chew on.
Right. So as you're designing that perfect AV control room, we've focused on the electronics. But I want you to consider the physical reality. What role do the environmental specs like an operating temperature between 32 and 104 degrees Fahrenheit and its physical rack dimensions play in the long-term stability of a room that's packed with heat-producing equipment?
That's a great point. That's where the operational costs, the real costs, can really bite you. Definitely something to think about.